Okay, given this list of points with their locations, their northings, eastings, and elevations and point numbers, I want to map them in QGIS. So because this spreadsheet has more than just those points in it, it has some other rows and columns, I want to just select them, copy them, and put them into like a notepad document. I prefer Notepad++, but just create a new one and paste them. Now I want it to be a comma separated values sheet, so that tab in the middle, if I highlight it and hit Control H, that highlight will be automatically placed in the look for box, and I'll replace it with a comma. So replace all. That should give me a comma separated values format. So I'm going to save it as and put it in a place where we can find it later, which be our, I'll give it a name, it'll be lawn.csv. It's around a lawn, and I need to change the type to all files so it'll respect that CSV extension, not put a .txt extension on it. And save. Okay. Now we can find QGIS and add the layer as a delimited text layer. Now, I just need to find that file again. And it'll read it as a CSV. I want to check a few. It looks like it's reading it correctly. Under the geometry definition, I want to make sure that my easting is the X field, the northing is the Y field, and I might as well put in, give it a, so it can respect the elevations as well. And these are in feet. That should work. We need to specify the projection, which is going to be, in our case, the New Mexico West state plane coordinate system, and we'll add it. And we'll look at the transformation settings, and we'll just okay that. There they are, and it looks like the blank QGIS project picked up that coordinate system as well. So here are our points. Looks like we have a stray point over here, so we can ignore it, and the next step would be to draw a traverse around it. So we have some external and internal points we can ignore in that one, but basically just around this edge. If we need to, we should probably label these points. So instead of no labels, single labels on the point descriptor. And that should work. Okay. Let's add another. Well, we can just add a regular vector layer, and well, we don't have that, so let me close that. Let's just go create a geopackage layer. How about that? Keep that in the same folder. We'll call that lawn T for traverse 1 for the first one. Set the geometry to a line string. So what we want to do is show these lines with their bearings and distances. Keep the project coordinate system. We won't set the fields yet, but we'll just go ahead and add this blank column. Okay, we'll start editing it and adding. Let me get the snapping toolbar turned on. Come over here, turn the snapping on. It's snapping to vertices here, and we'll start drawing just straight lines, and we'll just go clockwise, counterclockwise around this. After every line, I want to right click and auto generate a feature ID. So we'll just hit enter here, So click, click, right click, enter. Click, click, right click, enter, click, click. So we're going around the lawn this way. We'll see you when we're done. Okay, now that I've finished, I made one mistake. This point number 7 here is an interior point, so as long as I'm still editing, I can go to my vertex tool and just click on that vertex and reset that, and we'll save those. And stop editing. Well, I still need to calculate some stuff, so I'll keep the editing turned on, but save the edits with this box here. Okay. Let's open up the attribute table and take a look at our points. We want to calculate their lengths and directions first of all. So we'll go to the field calculator. Make a field called length, create a new field. Here we're not having any selected features. Make it a decimal. And I believe we can just do length. Bigger. So just the length. And this is going to be most likely in meters. So because that's the default units of QGIS. So I didn't change that, so I'm just going to go ahead and multiply that by 3.28084 to convert it to feet. And let's just run that. Now we have the length of these courses in the traverse. Let's add direction. Specifically the azimuth, that's all, as near as I can tell, that's all that QGIS can do with the tools. So we're going to make that a decimal number as well. And if we look at the geometry rollout here, expand that, there's azimuth and bearing, and they basically have the same description. So it is easier to work with azimuth to start with anyway. So the way it's formatted, we need to go ahead and double click it. Calculate the azimuth between 2 points, point A or point B. So for each line, we would use the start of each point. Of the geometry, and I think we have to type in at geometry a little bigger so we can see what's going on. Okay, start point geometry and end point at geometry, and then end the parentheses. So that does look like it's calculating it, but it's in radians, so we need to multiply that whole thing by 180 and divide it by pi. Pi is pi with an open and closed parentheses, and that looks like it's calculating the azimuth just fine. There is something to say, I guess, about the ellipsoidal direction versus the Cartesian direction. We're going to ignore that right now, but you can set that. Go ahead and click OK. I believe you can set that in the project properties. And yeah, we can just set the ellipsoid to none up at the top. So planimetric, if you want to calculate just not ellipsoidal directions. or distances for that matter. Anyway, we're going to leave it on ellipsoidal. Okay. Next step would be, I would like to label these, but not with their azimuths, but with their bearings. So we're going to convert this azimuth to bearings. One of the first steps to doing that is to create a north-south field and an east-west field. So let's do that. So I'll just call that NS for north-south. This one's going to be just a text field. It's going to have a single character in it, a north or a south. So I need an if statement to figure out whether it's in the north or south region. Maybe easiest to see if the direction field, and maybe I don't remember what it was called, but I can look right now. I called it azimuth, but we can certainly not have to remember it. We can just double click that. And so if the azimuth field is less than 270 degrees, that would be in the south, but it also has to be greater than 90, or else that's in the north. So if it's greater than 270 and it's, less than 270 and it's greater than 90, then we have, then it must be south. So I'll put a capital S in here. Get my cursor out of there. Nice. That out. Otherwise, so comma, and otherwise it'll be a north, and that's it. So that should calculate, take out some spaces here so it's easier to read maybe. There we go. So if the azimuth is less than 270 degrees and greater than 90, it's got to be south. Then between 90 and 170 basically. So it looks like there's no errors, so okay. Now we have a field with S's and N's in it, and we can see, we can check a few of the numbers. So we have 91 degrees is south, we have 316, which is north, and so forth. Okay, let's add an east-west column. Call it EW, make it text with one character, and we'll do the same sort of thing, but this time it's even a little simpler. So if the azimuth is what? If it's less than 180, then it's east, right? From 0 to 180, we're in the east region. And if it isn't, single quotes, we'll put west. If it's greater than 180, it's in the west column. Yep. Now that we have whether it's north or east, north or south or east or west, we can add the bearing angle. We can convert these azimuths to the actual bearing angle, and then we can convert that to degrees, minutes, and seconds. Okay, so I'm just going to abbreviate that BNG, ANG for bearing angle, and it's going to be a decimal number as well. And that's another if statement. So if the north-south column is an N, right? Then what do I do? Well, check if it's east and west. Right? So if the EW column is equal to an E, let's say, and single quotes, capital E, then I know it's northeast, and so the value of that bearing angle is the same as the azimuth, so I can just make it equal to the azimuth. If it's not east, then it's west, and therefore it's northwest. So the bearing angle would be 360 minus that azimuth. And I can end that. And so now if it's not north, I still need to know whether it's east or west. So I'm going to say if the EW column equal to E again, then it's southeast. And if it's southeast, then I would look at 180 minus the azimuth. For instance, if the azimuth was 179, that would be south 1 degree east. 180 minus 179 would be the 1. If it's 181, that would be in the west column. So the east-west column would be west, and the azimuth would be south 1 degree positive 1, so it would actually be just reversed. So that would be equal to the azimuth minus 180. And that takes care of all 4 possibilities. Northeast, northwest, southeast, and southwest. That's one way to do it. Another way to do it was mentioned in class earlier, was we could just look at the azimuth, and if the azimuth is less than 270, then we could set another if statement, and if it was if it was, we could ask another if statement. If it wasn't, it'd be north. And then if it was less than 180, then we would ask it another if statement, and if it wasn't, then we'd know it'd be between 270 and 180, therefore it would be southwest, and so forth. Then lastly, it'd be we could check for that last if statement. We still have 3 if statements, so either way, if it was less than 90, so if it was, it'd be north. If it wasn't, it'd be southeast. So similar logic, but here we go, and we can calculate those in degrees. So here are the bearing angles given in decimal degrees. So the next step would be to parse this out into degrees, minutes, and seconds. Let's add another column. We'll just call this D for degrees, and this is going to be an integer, and all we're going to do is use the floor function. We'll just use the floor of the bearing angle. I don't know if I spelled it that way, but yes, I did. So we're just going to take the floor of the bearing angle, and that's going to round it down no matter what it is. So the first number was 58 point whatever 696, and it's just truncating. There is no trunk function in QGIS, it's just floor, so that should work. So here are the degrees sections of all those bearing angles. We go to minutes now. So let's go minutes, and it's also going to be an integer. And we're going to still take that floor of the azimuth, and we're going to subtract it from the azimuth. But there's another way to do that. We can just take the the bearing angle, sorry. The bearing angle, and do a modulus of 1, and that will release that will produce the decimal remainder, basically. If I divide the bearing angle by 1, it'll be 58 with a remainder of 0.696 or whatever. So with that, I can multiply that by 60, and that'll give me minutes, because the decimal remainder of the degrees, I could just multiply the degrees by 60, and that would be how many minutes it is. But if I take out the whole portion of it and leave the remainder, or the decimal remainder of it, then I'll just get the minutes that I'm supposed to get. But I also need to floor that. So I'm going to floor that whole decimal minutes to get just the integer minutes. And so we have integer there. So we're getting 41 minutes. Lastly, we're going to do a similar thing, but we'll just take the modulus of the decimal minutes and multiply that by 60 to get the seconds. Let's do that. This will be a decimal, because we'll want to go maybe 1 decimal or 2 on the seconds. So again, we'll do a modulus with the bearing angle. And with 1, and multiply that by 60. instead, okay, this will give me my 41.7, and I need to just modulus that again and multiply that by 60. So the modulus is going to give me the remainder, and I multiply that by 60, and that'll give me my decimal seconds. Instead of flooring that, it'll give me an integer seconds, which is fine. I might just want to round it. Round this whole value to 1 or 2 decimal places. Now I have decimal seconds. This is all I need to, let's save those edits. All I need to label but with the length and the bearings of each line. Now, the labeling itself is fairly straightforward, but still, let's go to labels and single labels for each one, and let's just go to the expression on the expression builder for the labels themselves. First step, scooch that in a little bit so we can see a little better. First step is the length, so we'll just use the length column. Probably not a great name for the column because that's also a function, but in double quotes it should recognize it just fine. I also want to put a line break right after the length, and maybe even a foot tick mark so that it's in ticks. So the concatenation symbol, which is just double pipes, and then I'll put, well, I'd like to put a single foot tick on that, which is going to be a character function. There's probably another way to do this, but I think it's 039. Yes, looks like it. And then another concatenation, and I want a new line, so I have to put a line break in there. And then so I need a concatenation symbol between each one of these steps. The next would be the north-south field. So maybe I don't remember what I named it, but it's NS. And just double-click that. And I want a space after that, so concatenate. This I can put in double quotes, so just put a space. And then I want to put the degrees. There are the degrees. With the degrees, I want to put a degree symbol, which is a character 176, if I'm not mistaken. Yes. And then concatenate that. No spaces between the degrees, minutes, and seconds, I think. So we're going to concatenate that with minutes. And we're going to put another character 39 for the minutes tick. And concatenate that with seconds. Now seconds need, concatenate the seconds. I can put single quotes, I can put a double quotes and single quotes, but I need a space there too. So that's probably the easiest way to get the double tick for the seconds, and then a space, and then the east-west column. So that should, in the preview, I can see that I have a very long length, so I want to round that length to 3 decimal places, typically. That'll cut that down. The rest of them are already formatted well, so there we go. So there's my labeling. Most likely, I want to set the size to a little bit smaller, maybe 1/10 of an inch or 1/8 of an inch, so maybe 9 points. Under the formatting, I think the alignment should be center. I also think the placement should be on the line, not above the line, straddling the line, and perhaps my line spacing. Find it. Be careful rolling, because if you roll on a box, it'll change your value. Okay, so under formatting, the line height, I'll make that a little bit taller, maybe 120% or 110 or something. And let's just see what that looks like. maybe a little tall, but that's easily enough read. If I want to put a background image on it, I might put a mask. Actually, a halo works better, I think. So anyway, there we go, and we can lay this map out on a layout, which we can show in another video. But anyway, and that'll also help us to know whether the scale allows for some of the labels to show up or not. So we might have to deal with labels that for lines that are too short. So far, it looks like one of them is not. I might be inclined to reduce the size of the text to get that to fit, depending on the layout. So we'll just end that here. Thank you.